In this video lecture, we'll take a look at some common selection gotchas, some suggestions to avoiding them in the first place, and a few basic testing considerations. Okay, let's get started. Here's one common gotcha when creating selection logic, and that would be reliance upon default evaluation of logic. What we're trying to do in this example is to check if the value of x is equal to 2. If x is equal to 2, then with this inner logic, we want to check if x is also equal to y, and if so, print this first message. But if x is not equal to 2, we'd then like to print this second message. That's our intent. What really happens though is that this second message gets printed every time y is not equal to x, even for the case where x is equal to 2. Why does this happen? Well, it turns out that this else case gets paired with its nearest if case neighbor, which here is for the y equals x case. Even though we've written the code like so with explicit nesting to indicate what we want done, in this case it has no effect because Java is actually nesting our code for us using its defaults. By the way, for this course I never want to see your code turned in like this. Instead, use curly braces explicitly and liberally to clearly indicate your intentions. We can fix the preceding gotcha by being more explicit with our braces. In this version, by explicitly adding this one pair of braces in red, we explicitly force the evaluation of our logic in the way that we intend. Now this y equals x case is nested alone within this outer x equals 2 case as we intend. Just as a reminder of the coding standard for this course, be sure to always add braces for explicit evaluation of our logic, and always add these braces shown here in blue, even for single statement if or else branches. Here's another example of a common gotcha, the dangling else. This can occur whenever we inadvertently write some unbalanced code in which an else does not have any corresponding if. In this example, note that we have 2 if conditions, yet only 3 else cases, which is already a bad sign. This first else gets paired with its nearest if, then this second else gets paired with this outer if, but this third else has no corresponding if clause. And so when we try to compile this, it will generate a compiler error complaining about an else without an if. Although in this simple case it's not too hard to spot and fix the error, in more complex and longer code it can be very difficult. Rather than fixing problems, let's instead think in terms of avoiding problems in the first place. What principles or practices can we use to help us avoid such problems? Instead of fixing problems as they arise, it's better yet to avoid problems in the first place. So instead of thinking in terms of debugging, it's better to think in terms of anti-bugging instead. Here are some suggestions for you to consider as you write your code. Always use parentheses when you write your conditions. This not only enforces precedence, but it also makes your conditions more visually apparent in your code. Never, ever put a semicolon directly after your conditions. Although such code will compile, what it creates is an empty statement block. Any code that follows will always be executed. You can make this problem vanish by getting in the habit of always following a condition with an open curly brace. Speaking of braces, although they are not strictly required for single statement if blocks, it's a good practice to always use them, and we will consider that a required coding standard for this course. Get in the habit of always indenting the contents of any true or false block for code clarity. You probably already realize that I harp on this a lot, but it's a good coding practice and one that becomes increasingly important as our logic becomes more and more complex and deeply nested. Furthermore, it makes our code much more readable and can help in visually debugging if it's necessary. Finally, get in the habit of always aligning any closing brace with the beginning of its opening if statement. This is another thing I often harp on, but it's important to making your code more readable and being able to instantly spot any imbalanced statement blocks lacking their closing brace, which can be a tough compile error to spot. One of the best code development suggestions I can possibly make is to frame your code from the outside in first, rather than writing it in linear fashion from top to bottom on your screen. Start with the outermost logical framework of your code first, then gradually add in placeholder parenthesis pairs for your conditions, which you can add later. Whenever you add an opening curly brace, get in the habit of immediately adding its closing brace pair, lined up with the beginning of its opening statement. Then you can add any content later on to such block containers. Whenever you add another level of subordinate logic, always indent that code by 3 to 4 spaces so that you can better visually see the logical hierarchy. And finally, always use braces for every if, else, or else if clause, even though not strictly required. It just helps you better structure your code, and it makes it easier to add additional statements later on. Once again, this is a coding standard for this class. Always add a braces pair no matter what. To see some live examples of setting up a new program like this, please have a look at the demo video, which should be part of this week's lecture materials. The same types of suggestions hold for setting up new switch statements. Above all, always lay out the logical framework of your switch first, rather than trying to write it from top to bottom. Always use parentheses to enclose your switch expression, as we see up here. Indent all your case logic uniformly, and lay out all the cases you anticipate, giving them case conditions as shown, even if they are simply placeholders for now. Terminate every one of your cases with an indented break statement, as we see here. You can always delete them later if you need to group related cases for fall through. And always provide a default case as well. It's just a good practice. Once you have the overall framework of your new switch statement looking something like this, then it's much easier to add specific statements to the various cases as needed. To see some live examples of setting up a new program like this, please have a look at the demo video, which should be part of this week's lecture materials. In terms of testing software, at the risk of some oversimplification, there are two major types of testing: white box testing and black box testing. White box testing is the type of testing we might do upon our own code as software developers when we know all the internal details and expected behavior of our own code. Because we have this kind of specific insight into our code, we should devise a test plan with as many input data sets as needed to exercise every possible logic branch of the code. Then we can check those results against our program specification. In more practical terms for this class, what this means is we should run enough data through our code to where we have a pretty good feeling that we've exercised everything that it does, and everything works fine per the program assignment. We know how the code is supposed to behave. Make sure that all capabilities get exercised. I won't ask you to write any test plans in this course, but in a real-world setting, that would be a common part of any test planning. Black box testing is the opposite. This would be where someone unfamiliar with the internals of some code is still asked to execute it and make sure it works properly. In this case, all we could do would be to devise some test plan based upon any available program specifications and run enough different data input sets against that code to where we're confident that the program specs are being met. For example, if I was grading your program by simply running it with different data inputs without examining the details of how you've implemented the program, we might consider this a type of black box testing. In conclusion, and practically speaking, how do we go about testing our own code? Well, the first hurdle is always compilation. We have to make sure that our program passes its spell check and contains no syntax errors to prevent it from executing. No compilation, no execution. While it's always a relief when our code finally compiles cleanly and can give us some output, that's not quite enough. We have to make sure it's giving us the right results, so we have to test it enough to fix any possible logic errors. Software doesn't necessarily do what we want it to do. It always does what we told it to do. Needless to say, those aren't necessarily the same things. So to locate any remaining logic errors, for this course there are two main approaches. The one that most students wind up adopting is to add print statements liberally in their code. Put prints before and after troublesome calculations, echo out any intermediate results or input values used, use prints to indicate that you've reached various logical branches, and so forth. If you've seen movies where some doctor has probes hooked up all over some patient, it's kind of the same situation for the software. The main thing I would caution you on is to make sure to comment out or remove any such diagnostic print outputs before turning in your code, leaving only the display of outputs we're really interested in. The other main alternative is using the debugger, which you hopefully have seen multiple times in various code walkthroughs by this point. By using the debugger to step through execution of our code line by line, we can see exactly the path that the execution is taking and the values of any intermediate calculations at every step of the way. Even better, we don't need to guess at which points to add print statements or remember to disable or remove those diagnostic prints later. If you haven't already dabbled with it, I strongly suggest that you play with the debugger a little bit so you can use it in your own code development. Okay, and that wraps it up for this discussion of testing code and avoiding bugs in the first place.